Okay, so for today's topic, we're going to discuss under Module 4 yung analysis of structure. So, let's read first the introduction under 4.1. So, kunin ko lang yung highlighter natin. So, the process of the analysis of a structure. So, it is a process by which we determine how the loads applied to a structure are distributed throughout the structure. Okay, so for this module under analysis of structure, dalawang type of structure yung pag-aaralan natin dito. So una, we have the truss, and pangalawa, we have the pin-connected frames. So yung mga external load na dinadala ng isang structure, so ang goal kasi ng analysis of structure is paano ba or ano ba yung magiging internal effect ng mga externally applied load dun sa bawat member ng isang system or ng isang structure. Okay? Although there are many kinds of structure, we limit ourselves here to pin-connected types. Okay? Those that consist of assemblage of bars fastened together by smooth bolts. So yung mga member mo, sinabi naman dyan kung anong type ng connection siya. So yan ay pin-connected and it is fastened together by smooth bolts. Our purpose here is to determine the forces acting in the bars and upon the pins or hinges of the structure. In subsequent courses, we shall learn how to determine the dimensions of the various parts of a structure so they can safely resist these forces. Okay, so the two types of structure that will be studied here in this module is, yun nga, we have the pin-connected trusses and the pin-connected frames. So the essential difference between this type is that in trusses, the internal force, ito yung difference sila. So kapag sa truss, ayan, so the internal force in a bar is directed along the axis of the bar. Okay? So, meaning, if meron ka dito na, for example, meron kang truss, gawa lang ako ng isang simple truss. Ayan. So, kapag itong member na to, in-isolate mo, ayan. So, for example, I-section yung makikita natin na section na ginamit. Okay. So, yung load mo, ano ba sabi dyan, is directed along the axis of the bar. So, kapag truss problem naman, it's either in compression ka or tension and acting along the bar. So, acting along dito sa section na to. So, kung ito ay I-section, ayan. So, acting dito, ano? Or with reference to sa axis ng bar mo. Kung ito yung section ng bar, kung wari, ayan, rectangular shape. Nandito yung force, ano? So, it's either in tension siya or compression papaloob. Palabas or paloob. Acting along the axis. So, hindi siya yung nakatagilid. Straight lang siya along the axis. Okay? Whereas in frames, the members are subjected to bending action. So, kapag pin-connected frame, for example, ganyan. So, doon sa mga dugsungan niya, for example, isolate natin to. So, mga dugsungan yan, meron siyang component, yung mga internal force in y direction, meron siyang x, and at the same time, meron siyang bending moment or moment. Okay? So, ayan. So, again, the difference is kapag truss, yung internal force is acting along the section or acting along the bar, the axis of the bar. Meanwhile, for the frames, the members are subjected to bending action. So, meron siyang mga moment. And, ayan, meron siyang horizontal force. So, aside from the axial forces, meron siyang perpendicular force or yung bending force, and meron siyang corresponding moment. Occasionally, a structure is composed of members, some of which are subjected to axial forces, while others are subjected to bending action. So these are also called frames. Ayun nga. After we have learned how these types of structure are constructed, we shall see that the internal forces holding their various members in equilibrium create concurrent or non-concurrent system of forces in equilibrium. Okay, so these topics were discussed dun sa ating last module, which is the equilibrium of force system. So we have the concurrent force system and the non-concurrent system. Okay, so consequently, a force analysis of a structure consists of applying the conditions of equilibrium studied in the preceding chapter to determine the internal forces that act in or upon its various members. So ang objective nga natin dito guys is to determine yung mga forces na nag-a-act sa bawat member ng isang structure. Okay? So with that, papasok dyan yung principle or yung application na natutunan natin dun sa equilibrium of force system. So nandyan yung concurrent and non-concurrent system. So ano-ano nga yung gagamitin natin na equation dito? So tatlo lang naman yan guys. Summation of forces X, summation of forces Y, and summation ng moment. So all of that will be equals to 0. So dyan lang iikot yung ating Module 4, Analysis of Structure. So using this 3 equation, makukuha natin yung mga internal forces na andon sa isang structure natin, which is, sabi nga, ang connection ng mga structure na yan is naka-pin connected. Okay? So, next, 4.2. So, construction of simple trusses. Okay? So, ano ba yung truss? Dito, truss issues, ha? So, truss, so this is a structure composed of members fastened together in such a way as to resist changes in shape. So usually guys, isang clue rin para malaman mo if yung isang structure mo is a truss. Triangular kasi yung shape niya kadalasan. So for example, gawa ko ng isang structure na pin connected. Ayan. Okay? So guys, ang problema kasi dito sa type ng structure na to, if applyan ko siya ng horizontal load, ano mangyayari sa kanya? Ito kasi is may tendency na mag-sway o mag-move siya doon sa, depende doon sa pagkaka-apply ng force, which is going to the right. So, nangyari, nag-move siya or nag-bend papunta sa kanan. So, in order to resist this deformation or yung, hindi naman exactly deformation, but para maiwasan yung paggalaw nito, so naglalagay tayo ng diagonal members. Ayan. So to resist that, lalagay tayo ng ganyan. So para ma-resist niya yung paggalaw nung iyong ano. So meron ka ditong isang member which will resist this horizontal force. O parang bracing baga. Okay? So the purpose of a truss, ayan, is to support a larger load or span a greater distance than any individual member from which the truss may be built. So guys, I don't know if nakakapaglaro kayo ng mga application or yung games natin sa mobile phone. So meron kasi ako sang nalaro doon yung nagagawa ka ng bridge, ano. So you are required to, ayun nga, so ang concept ng game is, for example, may bangin na ganyan. So papadaanin mo yung sasakyan and then eto, meron kang limited amount ng material. So, parang magdi-design ka rin ng bridge. So, di ba yung sa larong yun, usually nagagawa tayo ng, ang shape na makikita mo is in the shape of a triangle. Okay, so, ayun nga, yun yung purpose ng truss para gawa siya ng great distance span kung saan yun, larger load yung kaya niyang suportahan. Ang concept kasi niyan is magpapasahan sila ng force, so yung dadaan na force dyan, hahati-hatiin ng bawat member. And etong concept nito is i-discuss rin siya dun sa moving loads under ng structural theory. Okay, so depende kasi yan sa location ng dumadaan kung saang part ng iyong structure makaka-experience ng maximum potential load. Ayun. So, habang dumadaan yung sasakyan, syempre, iba't ibang member yung makaka-experience ng ganun. And from that, aalamin mo kung aling member doon yung naka-experience ng greatest amount of load. So, parang doon mo ibabase yung magiging yung magiging material, kung anong size to, and kung anong section niya. Kumbaga, pangit namang kasi na iba't iba yung size nung di ba? Nung truss. So, maaaring dito, ganitong kalaki yung dapat mong ilagay, while dito, mas maliit. Though nangyayari naman yan, so iba't ibang pero kapag yung mga main member yung kino-consider, so syempre maganda, mas pare-pareho sila. And if yung member na yun is kaunti lang yung i-carry na load, so eto na, pwede na rin naman natin gamitin. Okay, so dyan kaya nga tayo nagde-design. Ayan. So, again, ang goal natin dito is, ayun nga, yung cost, at the same time, yung kanyang strength or the capacity to carry that load. Okay, so saan na tayo? So, to make a structure rigid, its member must be fastened together in such a way as to prevent any movement between them. So, a pin-connected structure meeting this condition is shown in figure 4-1. Ayan. And may example pala. So, sige, basahin muna natin. So, this structure is composed of 3 bars. A pin-connected structure composed of 4 bars arranged as shown in the figure 4-2 is not inherently rigid. So, it will collapse as indicated under the section of applied forces. So, ito rin yung parang pinaliwanag ko kanina. Okay? So, mas maganda daw na in order for it to considered as a rigid frame or a rigid structure, so 3 member siya. So, kapag 4 member yan, so once na na-applyan niya ng mga load, so may mag-tendency siya na deform or mawala do sa original shape niya. So, one option here is to provide a bracing para at least ma-fix siya. Fix, hindi gumalaw. So, in the construction of trusses, the basic design is 3 bar arranged to form a triangle. Ayan. So, triangle yung mafo-form dapat na shape ng 3 member. So, ito binubuo ng 3 member, AB, BC, and AC. So, while for this non-rigid frame, so binubuo siya ng 4 na member. So, to this base triangle in ABC, in figure 4-3, so, ibaba lang natin. Ayan. So, 2 more bars may be added to locate a joint D. Ayan. Which is rigid relatively to the other joint. So, since A and D are now fixed, relative to each other, 2 more bars may be added at these joints to fasten together at E. Okay, so ito yung 2 more bars to fasten at E. After which, 2 additional bar determined the F. Ayan. So, pasa-pasa lang. Thus, the continuing 2 add bars at joints rigid to one another, additional joints can be determined, and a truss consisting of many members may be constructed. Trusses built up in this manner are known as simple trusses. Okay? So, that is the formation of a truss. So, coming from, D, kinonect niya ng 2 member to form joint E. Okay? So, coming from A, ayan, papunta kay E, and so on. So, para magkaroon ka ng joint F, so, nagdagdag ka ng member from D to form the member DF, and member EF to form this joint, this member EF, para ma-join dito sa joint F, which is sa F, meron kang hinge support. Okay, so, basahin natin yung sunod. Trusses are usually supported by anchoring one joint to the foundation by means of a fixed hinge at F. Ayan. So, meron ka daw fixed hinge dyan. Since the truss could rotate about this hinge, rotational support is necessary. So this is supplied by mounting another joint, say joint A, on roller in such a way as to prevent that rotation. Then the truss is completely constrained against any movement. So note as well that a member in tension causes forces which pull away from its end joint, whereas a body in compression causes forces which push towards its end joints. So again, explanation lang naman dyan. Kapag tension, ayan nga, binabanat mo siya. So, andyan naman yan. Sabi nga, it tends to pull away from its end joint. Ito yung end joint, yung dulo. And then kapag compression, ayan, push towards its end joint. So, kinocompress mo siya. Okay, so dito guys, ayan, sige. Compress. Push toward its end joint. Okay? Okay, so the first method of analysis is yung tinatawag na method of joints. So, basahin natin. So, the force in truss members are determined on the assumption that the members is a two-forced member. Okay? So, napakahalaga nito. Hence, the forces acting on any pin form a concurrent system. So, when we say concurrent nga, they will meet or magtatagpo sila doon sa isang point. So, the condition of equilibrium for concurrent forces system from the basis of the method of joint. So, ano ba yung method of joint? So, again, gawa lang ako dito ng simple truss. Ayan. So, sabi nga doon sa unang, yung kaninang paragraph is, yung truss natin is supported by a fixed pin and a fixed roller. So, again, ang hinge mo or pin is, meron siyang dalawang reaction, and kapag roller, meron siyang isang reaction. So, perpendicular siya. So, ang parts niyan, ito guys yung tinatawag na joint. Ano ba yung sa katawan ng tao? Ano ba yung joint? Mga asukasuan ba yun? O ito yung mga dugsungan. Ano? Ayan. Ayan yung joint natin. So, ang sabi dito, two force member daw. Ang assumption natin sa bawat joint is two force member siya. So, bakit? Kasi nga, ang method of analysis natin dito is yung sa topic na concurrent system. So, they meet or they will meet at a common point. So, for example, eto. So, pangalanan natin is A, B, C, D, E, and F. Okay, so within this 1, 2, 3, 6 joints, so alin ba dyan yung masasatisfy yung first condition natin na dapat daw two force member lang yung kailangan nating consider? Okay, so tama. So, yung joint A and joint F, so ito yung mga joints kung saan ito yung pwede nating i-consider na unang joint na i-analyze. Okay, bakit? Kasi nga sabi doon sa ang method of analysis dyan is yung concurrent system kung saan kapag gumawa ka ng free body diagram dito sa joint A, o sige, yung joint F na lang para mas madali. Ano ba yung makikita nating mga forces doon sa joint F? So, gawa ka ng X and Y plane. So, una, meron ka ditong reaction. So, that is your RF. So, again, gaya nga ng sabi ko nung last meeting, ang initial step in solving a truss problem is to determine first the value of your reaction. Kasi, isasama mo yan sa analysis mo. Okay? So, for example, maglagay na lang din ako dito ng mga load. Ayan, lagyan ko dito ng 10. Ito, gawan ko ng 5. Ito, lagyan natin siguro ng 5 kN. Ayan. So, aside from that, just in case na mag-join tayo sa E, so, kasama rin sa point of analysis yung mga external load applied. So, isasama mo yung 5 kN na pababa. So, ano pa yung mga member na nandun sa joint F? So, meron ka ditong DF. Ayan. So, hindi pa natin alam yung direction. And meron ka dito na EF. Okay? So, ito yung technique ko kung paano ko na itatama agad yung mga direction. So again, ito nga is madidiscover mo rin sa dami ng problem na maisosolve mo. So sa analysis pa lang, ma-observe mo na ganito dapat yung mga direction ng member. Pero again, wag mag-alala kasi nung una, nanguhula lang ako eh. Inaalam ko lang kasi yung negative sign mo naman will tell you if tama or mali yung direction ng pagkaka-assume mo. Okay, so wag matatakot kung di sure to sa pagkaka-assume. Again, wala namang problema yan. So, yung negative sign niya, sasabihin niya kung tama o mali ang ano mo. Yung analysis mo or yung pagkaka-assume mo doon sa direction. So, DF, yung una kong aalamin yung direction. So, bakit? Kasi meron ka ditong value ng RF, which is known. Mahahanap mo yan eh. Ano ba yung RF mo? Di ba yan ay vertical force or yung force niya acts on the y-axis, which is pataas. Okay? So, since law of equilibrium nga, o equilibrium of force system yung atake natin dito, kung saan yung summation of forces y, which will be equals to 0. Okay? So, dito guys, iniba ko na yung ruling ko dito eh. So, before, lagi natin ginagawa na pataas is yung positive. Again, wala namang problema dyan. Ikaw naman kasi yung nagdidikta talaga niyan eh. Ano? Basta sinabi mo na lahat ng pataas dapat is positive. Pero actually, ito, pwede kong gawin na ang lahat ng pababa is yung positive. Sabi ko nga, akong bahala magdikta niyan kung alin ang gusto kong gawing positive, alin ang pwede kong gawing negative. Ganun lang din sa summation of forces x. Nasa sayo kung alin yung positive. Nasa sayo kung alin yung gusto mong negative. Basta yung equation mo, ganun dapat. Ano? So, ang ginagawa ko dito, ang pinagko-control ko ng direction na positive is yung unknown o yung hinahanap. Ang goal ko kasi is mapunta siya dito sa left part ng equation. So, dapat dito siya mapupunta. Ano? And then, lahat ng may mga values is ipipilit kong papuntahin dito sa right side ng equation. So, para at least diretso saksak na yun sa calcu. Hindi katulad ng i-simplify mo pa, iipod-ipod mo yung ano, dadalhin mo sa kabila, bago mo madala sa calcu. So, dito sa approach na to, diretso mo nang i-encode sa calcu. So, kung medyo kabisado mo na nga yan, hindi mo na kailangan sulat yung equation eh. Diretso saksak agad sa calcu. Kaya mo na siyang isolve. Okay. So, again, balik tayo dito. So, since ito is pataas, so therefore, ano dapat yung magiging direction ni DF para ma-counteract yung upward reaction ng RF? So, tama. So, dapat itong DF mo should be in compression. Bakit? Kasi yung Y component niyan, di ba ito may component kasi nakatagilid yan? Or it is acting at a certain angle. So, yung angle na yan, makukuha mo naman yung slope na to, ibibigay naman yan sa problem. So, di ba ito merong dalawang component? Meron siyang component Y, which is downward, and component X, kung saan papunta siya sa kanan. Okay? So, pag ganito dapat yung direction. Compression dapat yung iyong member DF. How about EF? Okay. So, sa EF, since dun sa DF mo, inassume mo siyang compression and yung X component niya is papunta sa kanan, therefore, yung EF mo should be tension or papunta sa kanan or palabas dun sa iyong joint F. Okay? So, para mabalanse niya yung system mo. Okay, so ganun, nag-a-assume ng direction ng force. But then again, if sakaling mali yung pagkaka-assume, wag mag-alala, the sign of the final answer will tell you if tama or mali ang nagawa mong assume ng direction. So technically, yun lang din naman yan. Itong i-discuss dito sa process ng or steps in solving a truss problem using method of joint. So ito na rin yung ginawa ko. Okay, so basahin na rin natin for step number 1. Ano ba sabi dyan? So step number 1, choose a pin. Or for this example, pili ka daw ng joint on which no more than 2 members acts. So maximum dalawa yan kung merong isa, pero I doubt na merong isa lang yung member. So dapat dalawa lang lagi. Kasi nga ang available equation mo lang na pwedeng gamitin is dalawa. summation of forces y, and summation of forces x. Yan lang yung pwede mong gawing equation. So, 2 equation, 2 ano lang yung kaya niyang gawin. Kapag tatlo na yan, so ibang usapan na yan. Diyan na papasok yung structural theory. So, analysis of complex truss or yung substitute member method. Okay? So, saan nyo na problemahin yan? Sa kanan yan papasakitin yung ulo nyo. So, dito muna tayo sa basic. Okay, so when the force in each member has been determined, it is indicated on the truss diagram by arrows at which end of the member. So these arrows act in the direction appropriate to the force. So toward the pin for compression, ayan siya. Kung papasok do sa pin or do sa joint, compression siya. And if away from it, so this is in tension, palabas. Okay, so toward the pin, yan, bumalik lang ako. When the force is in a member is determined and appropriate arrows are marked on the original truss diagram, the member is called the marked member. So guys, para lang din may progress yung pagsosolve nyo. So once na nakuha nyo na yung mga value do sa member EF and DF, so ginagawa ko kasi, pwede mo na siyang i-cross out. So nilalagyan ko ng markings na yan. So bakit? So, ang ibig sabihin ng mga markang yan, ibig sabihin meron akong value ng force na yon nung member ng may force na akong na-compute para sa member DF. Okay? So, ang method of joint kasi, palakad yung analysis niya. So, nagapang yan. So, coming from here, lalakad siya dito or dito. So, again, depende yan. Dapat no more than 2 members act. So, kung tapos na tayo dito sa joint F, between D and E, alin kaya dyan yung masasatisfy yung no more than 2 members act? Okay, so tama. Hindi pwedeng sa E yan. Kasi kung mapapansin nyo, though meron ka ng value ng EF, ilan members yung unknown? 3. Meron kang DE, meron kang BE, and meron kang CE. So, hindi mo talaga siya ma-compute. So, kahit anong equation ang gawin mo, 3 yung unknown, wala ang mapapalabas dyan. That's why mas maganda kung ang unahin mong joint is si joint D. Okay? And then, tsaka ka mag-joint E para mahanap yung member BE and CE and so on. Okay? So, ayan. So, sabi nga, markahan mo na yung mga member na nako-compute mo para at least kita mo siya kung alin joint yung sunod na mas magandang gawin. Next, for step number 2, draw the free body diagram of the pin or yung joint. So, yung pin dito guys, mas maganda if i-ano nyo na lang siya as joints. So, ayan nga, ito yung ginawa natin dito. Nagawa ako ng free body diagram para sa joint na yun. So, having only 2 unmarked members, assuming the forces in the unmarked members to be either tension or compression. So, mag-a-assume ka muna. Pero sabi ko nga, there's a way para tama agad yung assume mo. I-analyze mo na agad yung mga external load applied doon or yung value ng mga reaction. Next, solve the resulting equilibrium problem of concurrent forces for the unknown forces. Ayan. So, if a negative value, if a negative value is obtained, pag negative yung value na nakuha mo, for any force, the result will be correct. Yung result mo is correct pa din in magnitude, but opposite in direction. Baliktad lang yung direction. So, para doon, meron kang dalawang option again. Ito naman, lagi ko na sinasabi sa inyo before, it's either panghawakan mong negative siya, wag mong babaguhin yung direction, negative pa rin yung value niya. Or mas maganda, gawin mo siyang positive, tapos baliktarin mo yung direction. So kung na-assume mo siyang tension at yun ay nag-negative, ibig sabihin, gawin mo siyang positive, tapos gawin mo compression. Okay? Para at least tama na and hindi na magkalito-lito. Kasi minsan na kapag nagsusulat ka kasi ng negative napapaliit yung sulat po So akala mo dumi lang ang nailagay mo sa calcu or ang encode mo sa calcu is positive. So wala yan, mali na yung sagot mo. Ang masama dito guys, kapag nagkamali ka ng compute sa isang member, ano mangyayari? Dala-dala yung mga susunod na member. Chain effect yan. So kaya nga sabi ko, dapat yung mga equilibrium equation mo is master mo na gamitin. Okay, next, for step number 3. So, after determining the forces at a pin or at a joint, mark the original truss diagram with appropriate arrows at which end of the member whose force you have found. Remember that the arrows act away from the pin for tension and toward them for compression. So guys, ang sinasabi niya kasi dito is, for example, dito. So, ang ibig niya lang sabihin doon, if itong AB mo is in compression, so dapat, pag ganito yung mai-illustrate mo. Papasok. Kung dito is paganyan, so pagdating niya dito, ayan, compression siya, papunta doon sa mga joint A and B. And kapag tension, so palabas. Ayan, kung itong AC is tension, kung papunta dito sa AC, itong sa CA is pabaliktad. Pero ang gawa ko, ganito na lang. Minamarkahan ko yan na ganyan. Ayan. Tapos dito, for example, may napalabas akong DF. Tapos may lumabas na value, di ba? So, lalagyan ko dito ngayon ng symbol na C or kung wala ito si EFI tension. Ayan. Ayan. So, nilalagyan ko sa tabi ng C at T. So, ano bang ibig sabihin nun? Kapag C, compression yan, and kapag T, tension. Tapos, ang maganda dito, guys, gawa ka ng table doon sa pinakadulo ng ano mo, answer sheet. So, ilatag mo doon lahat ng members, AB, AC, BC, and so on, hanggang makapunta ka kay DF. Tapos, ilalagay ko dyan yung mga values. Ano? So, for example, ito yung magnitude, and then kung tension or compression siya. So, lalagyan ko lang dito, for example, si DF is in tension, tapos ang value niya is, for example lang, 33 kilo Newton. Ayan. So, para at least well-organized yung solution mo. So, kahit ako, kapag chinekan ko yung papel nyo, so, kahit silipin ko lang yung solution, tapos ang tingnan ko na lang stable, ayan, mas madaling mag-check and yun nga, sabi ko nga, organized yung solution natin. So, nasa na tayo? Number 3. So, after determining the forces at the joint, mark the original truss diagram with appropriate arrows. So, yun nga yun. Ayan. So, nasa sa inyo ha kung anong gusto nyong gawin. Pero, again, ito yung diskarte ko dito. So, for number 4, from the original truss diagram, select the next pin at which there are only 2 unmarked members. So, same rule applied. If 3 members yan before, bago ka mag-join yung unang joint, so, dapat, yung sunod mong i-consider na joint is nahanap na yung isang unknown do sa susunod. So, ito yung katulad dito sa example na sinabi ko. So, di ba hindi ka naman pwede mag-start sa D kasi 3 yung member na unknown dyan. So, dapat nga ulit is 2 lang. So, kaya ka nagsimula sa joint F. So, since meron ka ng value ng DF, eto. So, dyan ka pa lang pwede mag-joint D kasi 2 na lang yung unknown. Yung BD and yung DE, since yung DF is na kuha na natin when we take joint F. Okay? So, yun lang naman yung sinasabi ni step number 4. So, from the original diagram or truss diagram, select the next pin at which there are only 2 unmarked members, draw a new FPD, and determine the forces. Continuing this procedure until you have marked all the members, thereby indicating that the internal forces in all members have been found. So, in many cases, it is preferable to work from one end of the truss to the middle member. So, ang gawin mo daw, mula doon sa dulo, papunta doon sa gitna. Okay? So, a check on the accuracy of the calculation is obtained if the forces in the mid-member agreed as determined with these 2 independent method of analysis. So, ang pwedeng gawin nyo guys is, mula dito, for example, papunta doon. Ano? Tapos, tigil ka siguro dito sa BE. Ano? So, may makukuha ang value ng BE. Ang gawin mo sunod para at least, wait lang ha, nawala sa patas. Para lang at least may checking ka dun sa value ng BE. So, di ba dito ka nag-start sa joint A? Ang gawin mo ngayon, dito ka naman mag-start sa joint F. So, mahanap mong mga value is yung DF, EF, and dito ka rin mag-end sa member BE. So, dapat, yung mapapalabas mo na answer ng BE kapag dito ka nagsimula is pareho lang dito sa nung nagsimula ka doon sa joint A. Kasi nga, sa gitna rin matatapos, di ba? So, yun yung isang way para malaman mo if tama yung mga values na compute mo. So, dapat magpapareho yan. Kapag nagpanagpo sa gitna. Ngayon, if magkaiba yung answer na yan, dyan tayo medyo mahirap. So, magte-trace ba ka? So, saan ka ba nagkamali? Yung mga members from joint A, so, i-check mo yung mga equation mo. So, maaaring dito ka nagkamali or dun ka sa kabilang dulo nagkamali. So, either of that two, may possible na meron kang isang step na nagkamali ka dun. Basta ang way of checking yan, kapag itong member BE na yung kinompute mo, dapat pareho lang nasasagot if nag-start ka dito or nag-start ka dun sa joint F. Okay? So, let's proceed with the method of section. So, this is another way of solving a truss problem. Okay, so for method of section, so basahin ulit natin. If a cutting section is assumed to pass through the three members of a truss, and the cut members replaced by the internal loads being transmitted by the cut members, a free body diagram of a part of the truss is obtained which is acted upon by three unknown forces. So these three forces are determined by applying the condition of equilibrium of non-concurrent forces. So this technique is known as the method of section. So from the term itself, sectioning method, ang nangyayari kasi dyan guys is nagde-determine ka ng section line kung saan meron kang makakat na tatlong members. Okay? And ang mangyayari doon, it's either i-isolate mo yung left side or yung kabilang side yung i-consider mo for the point of analysis. And ang magiging atake dito is yung equilibrium of non-concurrent forces. Okay? So again, this was discussed from our past lecture. So ganito lang naman yung gusto niya sabihin. So, in a cutting plane, ayan. So, ina-assume muna natin guys na lagi silang in tension. So, itong DF mo, so tension yan, pag ganyan. So, yan yung DF. So, ito, DF lang din to. So, tension nga yan. Ayan. So, ilatag muna natin. Ba't DF ulit? So, this is EF. Ayan. And then ito EG. And then ito EG. Okay? So mangyayari dyan guys, sabi ko nga, it's either isolate mo yung isang side or yung kabilang side. So ang pwede mangyari, ito yung i-analyze natin. So isolate mo yan. Ayan. So ito yung i-analyze natin, itong side na to. Or kung ayaw mo yung kaliwa, pwede rin naman yung kanan. So, dapat pareho lang ng lalabas na sagot. So, guys, sa method of section, kasi magandang gamitin siya if ang mga required na member na pinapahanap sa'yo, lalo kapag ganyang long span, is, for example, sa exam, ang ipahanap ko lang na member is si EF, which is nasa gitna, di ba? Bandang gitna. So, ito lang yung meron kang chance na magka-point. So, instead na magsisimula ka ay joint A, after kay joint A, tatalong ka kay joint B. Diba, makukuha mo to sa joint A. So, sa joint B, makukuha mo to, makukuha mo to. So, ano sunod? Magjo-joint C ka pa. Makukuha mo to, makukuha mo to. Tapos, magjo-joint D ka. So, makukuha mo tong DF, makukuha mo tong DE. And then, joint E. So, dun mo palang makukuha yung EF, yung required sa problem. So, nakilang free body diagram ka? So, 1, 2, 3, 4, 5. So, 5 equilibrium equations ang gagawin mo, 5 free body diagram, which is napakahaba. Unlike dito sa method of section, magkakating section ka lang. Ayan. So, burahin ko lang yung mga pinagsusulat ko. Okay, so itira lang natin yung mga joint na yan. So, magka-ating section ka lang, ito yung i-analyze mo. So, considering this section, okay? So, para makuha yung EF, So, by method of section, pwede mong i-apply sa summation forces X, summation forces Y, and summation ng moment. So, anong pwede mong gawin dito? Ayan. So, imagine mo wala to Imagine natatakpan yun. Wala yun. Cross out natin yun. Ayan. So, ito lang yung pansinin mo So, ang pwede kong gawin para ma-compute ko yung EF, considering this section, magsasummation ako ng forces ng Y. Ano? Kasi itong EF ko, may Y component yan. So, ang gagawin ko, by taking summation ng forces Y, assuming, ayan, ito nga yung magko-control ng direction, upward direction as positive. So, yung EF ko, multiply, so sabihin ko, for example, ito ay 3, 4, 5. Multiply by 3 over 5. So, meron pa bang pataas? Ito, si 2, 5. Pero ang gagawin ko, equals ko na siya. So, yung 2.5 kapag transpose ko sa kabila is negative na. Tapos lahat ng pababa sa kabilang side is positive. So, 1,000 plus 1,000. So, meron pa bang force? So, ito. So, negative 2.5. So, mapapansin nyo dito, so, 2,000 minus 2.5, negative yung value. So, ibig sabihin pala, yung EF ko is supposedly compression siya. So, doon mo i-correct yung direction ni EF. Okay? So, again, kapag method of section, i-assume mo muna siya na tension. So, yun yung kasi nakaugalian. And then, once na nag-negative yan, tsaka mo i-correct itong direction to. So, ito pala dapat, guys, is compression. Ayan, para maging positive. So, tanggalin mo na to or gawin mong positive, tapos yung value niya. Okay, so ganun lang din. If hindi mo trip yung kaliwa, gusto mo yung kanan yung i-consider, so, ganun din. So, dapat pareho lang nalalabas na sagot. So, for example, ayan. Yun, meron palang isa pang diagram dito. Pakahirap pa tayo. So, for example, consider the truss shown in figure 4-13. So, if a section cuts through the member DF, EF, and EG, the truss may be separated into two parts, each of which is held in equilibrium by unknown forces equivalent to the loads being transmitted by these members. So, ayan. Okay, so sa member na to, sa example na to, itinama na niya yung direction. So, alam niya na siya ay compression. Kaya yung EF, papasok doon sa joint natin. Ayan. So, magkabilaan lang Ayan. So, yung DF pala, compression din daw. Pero again, kapag method of section, i-assume mo muna siya na intention. Okay, guys. For example, ganito ulit. Ayan yung problem natin. So, how about naman if gusto mong isolve yung value ng EG? Okay? So, again, this is an example of non-concurrent force system. So, ang gawin mo, bakit nasabing non-concurrent? Kasi hindi lahat sila is mag-meet sa common point. Itong DF and EF lang yung nag-meet. Itong EG, hindi siya tatagpo dito sa joint F. Okay? So, para makuha yung EG, ang pwede mong gawin, guys, is mag-moment ka dito sa point F. So, kapag in-extend mo yung line of action ng EF and DF, they will meet at a common point. So, kapag nag-moment ka dyan, makukuha mo yung value ng EG. So, considering these loads, ayan, isasama mo siya dun sa summation ng moment at joint F. Okay? F prime. So, mahanap mo yung value ng EG. So, ganun lang yung approach kay method of section. So, again, mas maganda siyang gamitin kapag yung mga unknown members is nasa loob ng iyong truss or nasa bandang pagitna. Lalo kung ganyan kahaba yung span ng bawat truss. So, ito, maikli pa nga to Pwedeng mga benteng, benteng ganito. Ayan. So, paano kung nasa pinakagitna yan at ang alam mo ay method of joint lang? Though kaya naman, kaso medyo mahaba lang. So, ayun. Ubus oras talaga siya. Okay, so basahin natin yung sunod. So, these two parts are shown in figure 4-14. Each part in this figure constitutes a system of non-concurrent forces in equilibrium. So, since the unknowns in either system are the same, it is generally best to determine the unknown from the equation of equilibrium applied to the simpler system. Here, at part A, is obviously the simpler system since it involves the fewer forces. Okay? So, ayun nga, mas madali nga naman yung nasa left side kasi kung mapapansin nyo, ang forces lang is 3, unlike dito sa kabila na 4. Ano? Okay, so the forces in the uncut members are internal to the force free body shown. Consequently, the forces in these uncut members occur in equal opposite pairs at their joint and hence cancel out of any calculation involving the entire free body. So, ayun nga, sinabi naman dyan na dapat equal opposite pair. So, kung ito is compression, dapat dito compression din para makakancel out lang din siya. So, to simplify the calculation, we use a condition of equilibrium that determines each unknown forces independently of the other unknowns. Usually, a moment summation is the best, the center of moment being chosen at the intersection of the unknown forces. So, kapag summation ng moment nga, expect mo na meron kang dalawang member or merong point doon kung saan yung dalawang member is magiging concurrent. With that, malalaman mo yung isang force kasi kung yung dalawa ay ma-eliminate na, so ibig sabihin may mahanap ka ng isa. Ayan, so thus in figure 4-14a, if the force in DF is desired, select E as the center of moment. So kung si DF daw yung kailangan, sa joint E ka mag-moment. Tama naman, kasi kung mapapansin nyo, dito sa joint E, kung gusto mo hanapin yung DF, tama, dito ka mag-moment sa E. Kasi yung force EF and EG is concurrent dito. So, mahahanap mo nga naman itong DF. So, to determine the force in EG, select the center of moment at the intersection of DF and EF. Thus, will be at the point F prime, giving the location of the original point F with respect to the left section. However, the moment method cannot be applied to determine EF because summation of forces may be taken to eliminate EG and DF from the calculation to determine EF. So guys, ito na lang yung tandaan. Kapag method of section, 3 equation ang pwede mong gamitin. So madadagdag si summation ng moment. So pwede ka mag-summation of forces X and summation of forces Y. Meanwhile, dito sa method of joint, dalawa lang yung equilibrium equation na pwede mong gamitin. Summation of forces X ka lang and summation of forces Y. Summation of moment is not applicable for this method. Okay, another advantages, method of joint. Maganda siyang gamitin if pinapahanap lahat ng forces sa lahat ng member sa isang truss. Method of section, magandang gamitin kapag nasa bandang gitna lang yung pinapahanap. Okay, so redundant members counter diagonal. I think we just need to skip this one. Pero basahin nyo na lang din. Pero ito, naano ko rin naman, hindi naman siya ganun kaano. Definition of a characteristic of 3-force member. So, ito yung sa method of frame. Okay? So, in the definition of characteristic of 3-force member, so structure containing 3-force member must be analyzed differently. Okay? So, a 3-force member is defined as one which supports 3 or more forces. So, kapag ganyan yung case, which is usually a pin-connected frame, so it is classified as a 3-force member. So, ito yung pin-connected frame. Therefore, because the direction of the internal force is unknown, neither the method of joint nor the method of section can be used. So at this age in the study of mechanics, all that can be done is to determine the forces acting at the pin joining the 3-force member. So the procedure is to isolate each 3-force member by means of free body diagram. On this diagram, the forces at the pins are resolved into rectangular components. When drawing the free body diagram of member which act mutually upon each other, these components should be shown as equal but oppositely directed on each free body diagram. So the simultaneous application of these conditions of equilibrium for non-concurrent forces to each free body diagram will be determined the unknown forces at the pin. Okay, so the method of members applied to frames containing 3-force member. So If some of or all the members of a pin-connected structure are subjected to bending action, the structure is called a frame. Ayan. So, 3-force member siya, and this is subjected to a bending action or bending force. Since it's not feasible to pass a section through the member of such structures, they are analyzed by considering the separate free body diagram of each 3-force member. The procedure is called the method of members. Ayan. So, method of members yung tawag sa pag-a-analyze ng isang 3-force member or isang frame. So, guys, ang mangyayari lang dyan, for example, meron ka ditong A-frame. Okay? Kung saan meron siyang kinakarry na, for example, lagyan natin dito ng load. Okay? So, ang sinasabi lang dyan, guys, is paghihiwalay-hiwalayin mo yung tatlong member na yan. Okay? So, ang mangyayari dyan, so, gawin ko itong green. Ayan. Tapos, eto. And then, tapos, meron ka ditong i-isolate ko na lang dito. Ayan. So, yung forces na nag-a-act dito is, ito nga, meron kang pin support. So, meron kang Y and meron kang X. So, dito, para makapal ito. Wait lang ha. Ayan. So, since ito may connection siya dito, so let's just say na meron ka ditong ganyan, meron kang paganto. Okay, so kapag nilipat, pag itong connection nito, itong horizontal member na yan, so kung dito'y pababa, dito, pataas siya. Tapos kung paaliwa dito, therefore dito, pakanan. Okay, and dito sa tuktok, meron siya ulit connection dyan. So, assume natin na paganyan and paganito. Okay? So, kapag kinonsider mo to isang member, so kung pababa dyan, dito, magiging pataas. And then kung pakanan dito, magiging pakaliwa. So, ganun lang yung analysis niyan. Isa-separate mo, gagawa ng, hatiin mo siya into its separate members, tapos gagawan mo siya ng free body diagram. Kung saan dapat lang siya, magbabalance. So, kung pataas yung direction mo doon sa isang side, dapat kapag doon sa isang connection niya, dapat pababa siya para makancel lang din yung ano. So, the essential principle involved in drawing the free body diagram of the several members of a frame is that of action and reaction. So, when separating the members for analysis, the forces usually represented by their components exerted by the connecting pins must be consistently represented as acting in opposite direction on the separated members. So, if either component of a force is incorrectly assumed in direction, ayan, so kapag mali daw yung assume ng direction yan, ba't ba ito laging yellow mark? The solution will still give its correct magnitude but with a negative sign. So, parang yung ano lang din sa truss. So, tama yung ano niya, yung value. Kaso nga lang, yung direction niya, mali ka lang na naging assume. So, ganun din, ang principle, itama mo, tapos baguhin mo yung direction. So, this would mean that the component of the force on both separated members acts in the opposite direction to that originally assumed. Okay, so that ends the discussion for this, So, mas ma-appreciate nyo naman siya. Itong mga explanation kasi yan. Medyo nakakatamad talaga siya. Pero kung intindihin mo, yun lang naman yung application yan, So, kapag sinolve mo kasi, tapos binasa mo ulit, sabi mo, magigets mo dun eh. Dun mo siya mas lalo magigets. Tama nga, ganun nga pala. Pero kahit ako naman noon, hindi ko na binabasa to, diretso sabak agad sa mga problem solving. Pero again, mahalaga rin naman to. Mahalaga talaga to, So, nandyan yung explanation niya. And mas mabivisualize mo siya kapag binasa mo siya. So, gawin nyo rin yung ginagawa ko, isolve nyo, tapos balikan nyo, basahin nyo ulit. Para at least mas mas ma-appreciate nyo siya or mas maunawaan. Ano? So, on our next video, so, andyan na yung mga example. So, ayun nga, mas maiintindihan nyo to sa mga example na yan. Okay, so, thank you and see you sa next videos natin. Peace out.